a little funky. So we're going to talk about some difference of squares situations that are not binomials. Now, I told you this day would come, but here's what makes a difference of squares. A difference of squares must have two square terms, and you must have a difference between them. In other words, they have to be subtraction. No, they don't have to be different. They have to be subtraction. So, looking at x, we have two terms that are perfect squares. We have a squared, which is a perfect square. So here's one perfect square here, as I select it stupidly. So here's one perfect square term. And then I also have the quantity x plus 1 squared. So this whole term is also a perfect square. Are we subtracting the two? We are subtracting the two. Therefore, this problem is in fact a difference of squares, even though it is not a simple binomial. You will remember when we talk about differences of squares that the answer to a difference of squares will have a pair of binomials where you have one addition and one subtraction. Then you will also remember that we have to take the square roots of both of our square terms. So what is, bless you, what is the square root of a squared? A. Okay. What is the square root of the quantity x plus 1 squared? What is the square root of the quantity x plus 1 squared? Margot?
X plus 1.
X plus 1. And I'm going to use a bracket here. So we have x plus 1 and x plus 1. So I have successfully factored this as a difference of squares, but I am not done. This is not in simplest form. I have a plus the quantity x plus 1. So this can just be written as a plus x plus 1. On the other side here, I have a negative in front of the x and the positive 1. So that means this negative sign gets distributed to both those terms. So my a remains positive, so I have a minus x minus 1. And that is my final answer. You will notice that I cannot say anything is squared because these are not identical binomials. There is a distinct difference in the signs. So the same thing can happen again in this one. So again, I'll have my binomial pair of factors. It's a difference of squares, so I'll have one addition and one subtraction. What is the square root of 16?
4.
What is the square root of the quantity 2x plus y squared?
Quantity 2x plus 1.
Same thing goes here. So we have the 4 here minus 2x plus y. And then we have to simplify it. My first term, I only have addition signs. So Sam will tell me that we will just end up with 4 plus 2x plus y. But in my other term, I have to distribute that. And I would end up with 4 minus 2x minus y. Question Z is no more different. But this is merging the two things that we've been talking about this week. First, factoring by grouping, and the other, factoring by using a difference of squares. So we have a polynomial. All four terms do not share a common monomial. I cannot factor as a difference of squares. I cannot factor as a square binomial. And I know that a binomial pair of factors, when multiplied together, will only give me a trinomial. So I have to group this. So since this is the only y factor, if I group here, Will I be able to get the same binomials?
No.
No, I will not. So then, where is the most logical place to group? Well, I can group it here. X squared plus 10x plus 25 can be factored to x plus 5 times x plus 5. But wait a second, if I'm multiplying something by itself, what's a simpler way of writing it?
It's the square.
X plus 5 squared minus the y squared. This, my friends, is a difference of squares, which would be factored to x plus 5 plus y times x plus 5 minus y. So here's the square root of your first term. And again, here's the square root of that first term.
All right.
All right.
Cool.